Let me show you a number. A number so small that it has no meaning in practical terms. A number that represents the probability of first contact between humanity and an alien civilization. When you calculate it properly, when you account for all the factors, when you multiply all the probabilities together, you get a number indistinguishable from zero. This is not pessimism. This is not speculation. This is mathematics. The same mathematics that predicts eclipses and designs spacecraft and describes the behavior of atoms. When you apply rigorous probability theory to the question of first contact, the answer is devastating. It cannot happen. The numbers forbid it. For generations, we have dreamed of first contact, the moment when we discover we are not alone, the message from the stars that transforms human history, the arrival of beings from another world. These dreams have inspired countless stories, motivated scientific searches, shaped how we think about our place in the cosmos. But dreams are not mathematics. Hope is not probability. Wanting something to be true does not make it possible. When you strip away the emotion and look at the numbers, when you calculate the actual probability of first contact, you discover something that changes everything. The probability is essentially zero. Not small, not unlikely zero. So close to zero that the difference does not matter. First contact is not just improbable. It is mathematically impossible in any meaningful sense of the word. We have been asking the wrong question for decades. We have been asking whether aliens exist. The answer to that question is almost certainly yes. The universe is vast beyond comprehension. Billions of galaxies, each containing billions of stars, each potentially hosting planets. The probability of Earth being the only world with intelligent life approaches zero. But existence is not the same as contact. Aliens can exist without us ever meeting them. Aliens can exist without us ever detecting them. Aliens can exist without us ever knowing they exist. The question of existence and the question of contact are completely different questions, with completely different answers. Frank Drake understood this distinction. In 1961, he created what became known as the Drake equation. It was an attempt to estimate the number of communicating civilizations in our galaxy. The equation multiplied together factors like the rate of star formation, the fraction of stars with planets, the probability of life emerging, and the lifetime of technological civilizations. The Drake equation was brilliant as a framework for thinking about the problem, but it had a fatal flaw. It asked how many civilizations exist. It did not ask how many civilizations we could actually contact. These are very different questions. And the second question has a much more disturbing answer. Let me walk you through the mathematics of contact. Let me show you how the probability cascades downward at every step. Let me demonstrate why, even if the galaxy is teeming with intelligent life, first contact remains mathematically impossible. The first factor is the probability that an alien civilization exists right now. Not existed in the past. Not will exist in the future. Right now at this moment, contemporaneous with human civilization. This is not guaranteed even if civilizations are common. The universe is about 14 billion years old. Our galaxy is about 13 billion years old. Civilizations could have emerged at any point in this vast span of time. If a civilization emerged 1 billion years ago and lasted for 1 million years, it has been extinct for 999 million years. It existed, but not now. Think about what this means. A civilization could have risen to greatness, developed technology far beyond our imagination, spread across their region of the galaxy, and then collapsed into extinction all before the Earth even formed. They existed, they were real, but they were separated from us by billions of years. Conversely, civilizations might emerge billions of years from now, long after humanity has gone extinct. They will look at the stars and wonder if they are alone, never knowing that we once existed. The universe is vast in time as well as space, And this temporal vastness creates a synchronization problem that mathematics makes nearly impossible to solve. Carl Sagan thought deeply about this temporal problem. He recognized that the lifetime of civilizations was the crucial variable. If civilizations typically destroy themselves within a few centuries of developing technology, then the galaxy at any given moment contains very few civilizations. Even if many have existed over cosmic time, let us be optimistic. Let us assume that right now, at this moment, there are 1,000 technological civilizations in our galaxy. This is probably generous, but it gives us a starting point. 1,000 civilizations among 400 billion stars. The probability that any randomly selected star hosts a civilization right now is about 1 in 400 million. But we are not interested in random stars. We are interested in stars close enough for contact to be possible. This introduces the second factor, the probability that a civilization is within contactable range. What is contactable range? This depends on what we mean by contact. If we mean receiving signals, the range might be a few hundred light years at most. If we mean physical visitation, the range is essentially zero, as we have discussed in other contexts. Let us be generous and say contactable range is 1,000 light years. The galaxy is 100,000 light years across. A sphere of radius 1,000 light years contains about 1/3 millionth of the galaxy's volume. If civilizations are distributed randomly throughout the galaxy, the probability of even one being within our contactable range is small. Let me help you visualize this. Imagine the galaxy as a disk, 100 kilometers across. At this scale, our contactable range would be a circle about 1 kilometer in diameter. We are looking for another civilization somewhere in that 100-kilometer disk, hoping they happen to be within our 1-kilometer circle. Even worse, we do not know where to look. Civilizations could be anywhere. They are not marked on a map. They do not emit signals we can track. They are hidden among 400 billion stars, and we can only meaningfully search a tiny fraction of that number. With 1,000 civilizations distributed randomly across the galaxy, the expected number within 1,000 light-years of Earth is about 0.3, less than 1. There is roughly a 70% chance that the nearest civilization is more than 1,000 light-years away, too far for any meaningful contact. But let us continue. Let us assume, against the odds, that there is one civilization within contactable range. The third factor is the probability that they are transmitting signals we can detect. This is not guaranteed. In fact, it may be unlikely. Why would a civilization broadcast detectable signals? Our own civilization has been transmitting for about 100 years, but we are already transitioning to less detectable communication methods. Fiber optics, directional beams, encrypted signals. Our period of being electromagnetically loud is brief. This is a pattern that might be universal. Early technology is inefficient and wasteful. Radio broadcasts spray energy in all directions. Primitive radars pulse out signals that anyone can detect. But as technology matures, it becomes more efficient. Signals become focused. Communications become encrypted. The electromagnetic signature fades. We can see this in our own history. The 1950s and 60s were the peak of human electromagnetic loudness. Powerful television stations, radar installations, early space communications. Today, much of our communication travels through fiber optics, invisible to radio telescopes. Our cell phones use weak directional signals. We are becoming electromagnetically quiet. If this pattern is universal, then every civilization goes through a brief loud phase, then becomes quiet. The window of detectability might be only a few centuries in a civilization's entire existence. Miss that window and you miss the civilization entirely. Seth Shostak, senior astronomer at the SETI Institute, has estimated that the window of detectability for a civilization might be only a few centuries. After that, they either destroy themselves, or their technology becomes too advanced and efficient to leak detectable signals, or they deliberately go silent. If civilizations are detectable for only 300 years out of a million-year existence, the probability of catching them during their detectable phase is 0.03%, 1 in 3,000. Even if a civilization exists within range, we are unlikely to detect them. Let us continue the calculation. We have assumed 1,000 civilizations exist, that one is within range, and that we catch them during their detectable phase. The fourth factor is the probability that they are transmitting in a direction and at a frequency we are monitoring. The electromagnetic spectrum is vast. Radio waves span frequencies from a few kilohertz to hundreds of gigahertz. Within this range, there are billions of possible channels. SETI researchers focus on certain frequencies, like the hydrogen line at 1420 MHz, but this is based on human assumptions about what aliens might choose. Jill Tarter has acknowledged this limitation. We are guessing where to tune our receivers. If aliens transmit at frequencies we are not monitoring, we will miss their signals entirely. The probability that they happen to use frequencies we are checking is unknown but likely small. Furthermore, signals can be directional. If aliens are transmitting focused beams to conserve energy, those beams need to be pointed at us. The probability that they happen to be aiming at our solar system, among hundreds of billions of possible targets, is approximately 1 in hundreds of billions. Let us be generous again and combine these factors. Assume there is a 1% chance that aliens are transmitting at frequencies and directions we can detect. This is probably optimistic, but it allows the calculation to continue. The fifth factor is the probability that their signals are strong enough to be detected. This is governed by physics, specifically the inverse square law. Signals spread out as they travel, becoming weaker with the square of the distance. A signal that is powerful at its source becomes a whisper at interstellar distances. The inverse square law is merciless. Double the distance, and the signal strength drops to 1/4. Increase the distance by 10, and the signal drops to 1/100th. At interstellar distances, signals that were powerful at their source fade to essentially nothing. Consider the most powerful radio signal ever broadcast by humanity. The Arecibo planetary radar could transmit about 20 trillion watts of effective radiated power in a focused beam. This sounds enormous. But at the distance of the nearest star, that signal would be weaker than the cosmic background noise. It would be undetectable. We have discussed this in detail elsewhere. The mathematics is unforgiving. To send a signal detectable at 1,000 light-years would require power comparable to the output of a star. Most civilizations probably cannot or will not expend such resources on speculative communication. Even if a civilization wanted to be heard, even if they dedicated significant resources to broadcasting, the physics works against them. Signals fade, noise accumulates. Detection becomes impossible not because of inadequate technology, but because of fundamental physical limits. Let us assume, generously, that there is a 10% chance the signal is strong enough to detect. This combines with all the previous factors. The sixth factor is the probability that we recognize the signal as artificial. This is not trivial. The universe is full of natural phenomena that produce regular, patterned signals: pulsars, quasars, masers. How do we distinguish artificial signals from natural ones? When pulsars were first discovered in 1967, astronomers thought they might be alien signals. The pulses were so regular, so precise, that they seemed designed. The researchers called them LGM, little green men, half-jokingly. But the signals were natural, rotating neutron stars, not alien beacons. The universe is full of objects that produce regular repeating signals. We cannot assume that regular signals are artificial. We need additional evidence. We need patterns that could not plausibly be natural. But what patterns qualify? This is uncertain. We assume artificial signals would have certain characteristics: mathematical patterns, prime numbers, narrow bandwidth. But these assumptions are based on human thinking. Alien signals might not conform to our expectations. We might receive a genuine alien transmission and dismiss it as natural noise. Conversely, we might detect a natural phenomenon and mistakenly believe it is artificial. False positives have occurred throughout the history of SETI. The WOW signal of 1977 remains unexplained, but has never been repeated. It might have been alien. It might have been terrestrial interference. It might have been a natural phenomenon we do not understand. The recognition problem is fundamental. We do not have a reliable way to distinguish artificial from natural signals. We make assumptions, but assumptions can be wrong. An alien signal might look natural to us. A natural signal might look artificial. Paul Davies, theoretical physicist and astrobiology researcher, has written about this recognition problem extensively. He suggests that our assumptions about what alien signals would look like might be completely wrong. We might be filtering out the very signals we are looking for. Let us assume there is a 50% chance we would recognize a genuine alien signal. This is probably optimistic given the uncertainties involved. Now let us multiply all these probabilities together. This is how probability works. When events must all occur for an outcome to happen, you multiply their individual probabilities. This is elementary probability theory, but its implications are profound. We are not adding probabilities, which would give a larger number. We are multiplying them, which gives a much smaller number. Each factor less than 1 makes the product smaller. Many factors much less than 1 make the product tiny. Start with the probability that a civilization exists within range. Call it 30%, being optimistic. Multiply by the probability they are in their detectable phase, 0.03%. Multiply by the probability they are transmitting at frequencies and directions we monitor, 1%. Multiply by the probability the signal is strong enough, 10%. Multiply by the probability we recognize it, 50%. 0.3 times 0.0003 times 0.01 times 0.1 times 0.5 equals approximately 0.00000045. We have dropped 7 orders of magnitude just from these 5 factors. The result is 0.00000045%. That is about 4.5 chances in 10 million for receiving a single signal under optimistic assumptions. The probability of actual first contact involving two-way communication is even smaller. And remember, we made optimistic assumptions at every step. We assumed 1,000 civilizations exist. We assumed one might be within range. We assumed 300 years of detectability. We assumed 1% chance of frequency alignment. We assumed 10% signal strength. We assumed 50% recognition. If we used pessimistic but reasonable assumptions, the probability would be much lower. The number of civilizations might be 100, not 1,000. The detectable window might be 50 years, not 300. The signal strength probability might be 1%, not 10%. But we have not even considered all the factors yet. We assumed 1,000 civilizations exist right now. What if that number is lower? We assumed a generous detection range. What if signals fade faster? We assumed civilizations would broadcast. What if they do not? Each assumption we made was optimistic. Each probability we assigned was generous. The true probability is almost certainly lower than our calculation suggests. When you account for all the uncertainties, when you include all the factors, the probability of first contact becomes indistinguishable from zero. Let me approach this from another angle: the Fermi paradox. In 1950, physicist Enrico Fermi famously asked, "Where is everybody? If the galaxy is old enough and large enough to contain many civilizations, why have we seen no evidence of them?" The paradox has spawned countless proposed solutions. Maybe civilizations destroy themselves. Maybe they are hiding. Maybe they have transcended physical form. Maybe they are so alien we cannot recognize them. Maybe they are already here and we do not know it. But our probability analysis suggests a simpler solution. The paradox has already been solved. The answer is that contact is mathematically impossible. Civilizations might exist in abundance, but the probability of contact rounds to zero. This is perhaps the least satisfying solution emotionally. We want there to be a reason. We want to believe that if we just do something differently, contact could happen. We want the silence to be a choice, not a necessity, but mathematics does not care about our emotional preferences. The paradox is not a paradox at all when you understand the probabilities. There is no mystery about why we have not detected aliens. The probability of detecting them is essentially zero. The mystery would be if we had detected them. That would require explanation. The silence requires none. This is not a satisfying answer emotionally. We want the universe to be connected. We want civilizations to communicate across the stars. We want first contact to be possible, even if difficult. But mathematics does not care about our desires. Mathematics describes what is, not what we wish. Robin Hanson, economist and researcher, proposed the concept of the Great Filter. He suggested that somewhere in the development from simple chemistry to spacefaring civilization, there is a barrier that almost no life passes through. Our probability analysis suggests there may be many filters, not just one. Each step in the path to contact has a probability less than 1, and the probabilities multiply. The original Great Filter concept imagined a single dramatic barrier. Perhaps life rarely emerges. Perhaps intelligence rarely evolves. Perhaps civilizations usually destroy themselves before developing advanced technology. One big filter that explains the silence, but our analysis suggests something different. The filter is not one barrier but many. Each step from existence to contact has its own probability. Life must emerge. Intelligence must evolve. Technology must develop. Civilizations must survive. They must be contemporaneous with us. They must be close enough. They must transmit. They must use frequencies we monitor. They must be strong enough. We must recognize them. Each of these is a filter. Each reduces the probability together. They filter the initial possibility of contact down to essentially zero. The Great Filter is not one event, but the multiplication of many small probabilities. The Great Filter might not be a single dramatic barrier. It might be an accumulation of ordinary improbabilities. Each step is possible. Each transition can happen. But the combined probability of all steps happening in the right sequence at the right time is essentially zero. Let me consider another approach to the mathematics. The Drake equation traditionally estimates the number of civilizations, but we can modify it to estimate the probability of contact. This requires adding terms that Drake did not include. The original Drake equation was revolutionary in its time. It provided a framework for thinking systematically about extraterrestrial intelligence, but it was designed to answer a different question. It asked how many civilizations exist. We need to ask how many civilizations we can contact. We need terms for the probability that civilizations transmit detectable signals. We need terms for the probability of temporal overlap. We need terms for the probability of spatial proximity. We need terms for the probability of frequency alignment. We need terms for the probability of signal strength. We need terms for the probability of recognition. Let me write out this modified equation in words. The probability of contact equals the probability that civilizations exist, times the probability they exist now, times the probability they are within range, times the probability they are transmitting, times the probability they are using detectable frequencies, times the probability their signals are strong enough, times the probability we recognize them, times the probability we can respond, times the probability they receive our response. Each of these terms is less than 1. Most of them are much less than 1. When you multiply them together, the result is tiny. It does not matter much what values you assign. The structure of the equation guarantees a small result. When you add all these terms and multiply them together, the result is always very small. It does not matter much what values you assign to the original Drake variables. The contact probability remains near zero because the additional terms are so small. Sarah Seeger, astrophysicist and planetary scientist, has worked on similar probability analyses for detecting biosignatures on exoplanets. Her work shows how quickly probabilities can collapse when multiple conditions must be satisfied. Each condition seems achievable, but the conjunction becomes vanishingly unlikely. This is a general feature of probability theory. When you require multiple independent events to all occur, the combined probability is the product of the individual probabilities. Even if each individual probability is reasonably high, say 50%, requiring 10 such events gives a combined probability of less than 0.1%. For first contact, we require not 10 events but dozens, and most of the individual probabilities are much lower than 50%. The mathematical conclusion is inescapable. First contact has a probability so low that it will not happen within any reasonable time frame. You might object that we are being too pessimistic. Perhaps some of our probability estimates are wrong. Perhaps civilizations are more common, or more detectable, or more long-lived than we assume. This is possible, but changing individual estimates does not change the fundamental conclusion. This is an important point, so let me explain it carefully. When a conclusion depends on a single uncertain estimate, changing that estimate can change the conclusion. But when a conclusion depends on many independent factors, the conclusion becomes robust. Even large errors in individual estimates cannot rescue the final result. Think of it like a chain with many weak links. Strengthening any one link does not make the chain strong. You would have to strengthen every link, and in our probability chain, every link is weak. Every factor is less than 1. Every multiplication makes the result smaller. The reason is that we require many independent factors to all align. Even if we are wrong about some factors, we are unlikely to be wrong about all of them. The multiplication of probabilities ensures that the final result remains very small, even with optimistic revisions. Scientists call this the conjunction fallacy in reverse. We naturally underestimate how unlikely conjunctions are. When told that multiple things must all happen, we tend to think it is achievable if each thing is achievable. But the math says otherwise. Multiply enough fractions together and you get essentially zero. Let me illustrate with an example. Suppose we were wrong by a factor of 10 on every estimate. Suppose civilizations are 10 times more common, 10 times longer, lived 10 times more likely to broadcast, 10 times easier to detect, and so on across all our factors. Even with these enormous corrections, the probability of contact increases by a factor of 10 raised to the power of however many factors we have. If we have 10 factors, that is a factor of 10 billion improvement. But if our original probability was 1 in 10 trillion, the improved probability is still only 1 in 1,000. 1 in 1,000 might sound achievable over cosmic timescales. But remember, this is the probability of detecting a single signal, not of establishing meaningful two-way contact. Actual first contact requires many more steps, each with its own probability less than 1. Let me be clear about what true first contact would require. It is not enough to detect a signal. We would need to confirm the signal is genuinely extraterrestrial. We would need to rule out all natural explanations. We would need to decode whatever information the signal contains. Then we would need to formulate a response. What do we say? Who speaks for humanity? These are not just practical questions. They are questions that could take decades to resolve. International cooperation, scientific consensus, political agreement. None of this is easy or fast. Then we would need to transmit our response with enough power to be received. We would need to aim at the right location, accounting for the motion of stars over the time our signal travels. We would need to wait years, decades, or centuries for our signal to arrive. Then we would need them to detect our response. They face the same detection challenges we do. Their instruments must be listening. They must recognize our signal as artificial. They must decode it. They must choose to respond. Then we would need to wait again for their response to reach us. The round trip time is twice the distance in light years. For a civilization 100 light years away, that is 200 years minimum between our response and their reply. For a civilization 1,000 light years away, 2,000 years. True first contact would require not just detecting a signal, but confirming it is alien, understanding its content, formulating a response, transmitting that response, having it received and understood, and receiving a reply. Each step multiplies more probabilities. The final result remains essentially zero. Geoffrey Marcy, astronomer who discovered many of the first exoplanets, has reflected on these probabilities. Despite dedicating his career to finding planets that might host life, he acknowledges that the probability of contact remains discouragingly low. The planets might be there, the life might be there, but the contact will not happen. This is the sobering conclusion of mathematical analysis. First contact is not just difficult. It is not just unlikely. It is mathematically impossible in any practical sense. The probability is so low that expecting it to happen is like expecting to win the lottery every day for a year. Let me put this in perspective with some comparisons. The probability of first contact is lower than the probability of being struck by lightning. It is lower than the probability of winning a major lottery. It is lower than many events we consider essentially impossible in everyday life. We do not plan our lives around being struck by lightning. We do not count on winning the lottery. We recognize that some events, while technically possible, are so unlikely that they will not happen to us. First contact falls into this category, but it is even less likely than these already unlikely events. Some events are so improbable that they never happen in practice, even if they are technically possible. A deck of cards could shuffle into perfect order, but it never will. Your cells could quantum tunnel through a wall, but you will never walk through one. First contact falls into this category of technical possibility with practical impossibility. Physicists have a name for this: thermodynamic impossibility. Events that are not forbidden by fundamental laws, but are so unlikely that they effectively never occur. The entropy of a closed system could spontaneously decrease, but we never observe this. First contact is similar, not forbidden, but effectively impossible. What should we do with this mathematical conclusion? How should we respond to the certainty that first contact will not happen? I believe the answer is acceptance, and acceptance leads to redirection. We have spent decades hoping for contact. We have built radio telescopes and trained them on the stars. We have sent messages into the void. We have imagined aliens receiving our broadcasts and responding. These were beautiful dreams, but mathematics has revealed them as impossible dreams. The SETI program represents one of humanity's most ambitious scientific projects. For over 60 years, dedicated researchers have scanned the skies. They have developed sophisticated technology. They have analyzed billions of data points. They have done everything right, and they have found nothing. The silence has been absolute. No confirmed signal. No evidence of extraterrestrial intelligence. Just the hiss of cosmic background noise and the occasional false alarm that turned out to be terrestrial interference or natural phenomena. This is not a failure of the researchers. They did their job. They asked an important question and sought an answer. The answer turned out to be no. That is how science works. Sometimes the answer is no, but the mathematics explains why the answer was no. The probability of detecting a signal was always essentially zero. The search was valuable because we did not know this with certainty until we tried. Now we know. The mathematics was confirmed by experience. The redirection is toward what is possible. We cannot contact alien civilizations, but we can contact each other. We cannot receive messages from the stars, but we can create messages for each other. We cannot join a galactic community, but we can build our terrestrial community. This is not a consolation prize. This is the actual prize. The cosmic community we imagined was always a fantasy. The human community we have is real. The alien wisdom we hope to receive never existed. The human wisdom we can share with each other is right here. Think about what we were really looking for when we dreamed of first contact. We were looking for connection. We were looking for meaning. We were looking for confirmation that intelligence matters in the universe. We were looking for someone to talk to. We already have all of those things. We have connection with each other. We have meaning that we create together. We have confirmation that intelligence exists because we exist. We have billions of someones to talk to right here on Earth. Carl Sagan, who perhaps more than anyone inspired the dream of cosmic contact, also understood this redirection. In his later work, he focused increasingly on the preciousness of Earth, on the importance of human cooperation, on the responsibility we bear for our own future. He never stopped wondering about alien life, but he knew that our fate was in our own hands. The mathematics of contact is final. The probabilities have been calculated. The multiplications have been performed. The result is zero in any practical sense. First contact is mathematically impossible, and accepting this frees us to focus on what actually matters. Let me be explicit about what this conclusion means. It means we will never receive a signal from an alien civilization. It means no alien ship will ever land on Earth. It means no message from the stars will ever transform human history. It means we are alone for all practical purposes. This is a profound conclusion. It answers one of humanity's oldest questions. Are we alone? The answer is yes, in every sense that matters. We might share the universe with other intelligences, but we will never know them. We will never communicate with them. We will never meet them. Some will refuse to accept this conclusion. They will hope that we are wrong about some factor. They will point to uncertainties in our estimates. They will argue that mathematics cannot predict the future with certainty. And they are right that certainty is impossible in empirical matters. But practical certainty is possible. We are as certain about this as we are about many things we treat as certain. We are as certain as we are that the sun will rise tomorrow. We are as certain as we are that dropped objects will fall. The mathematics is that clear. What matters is not the aliens who will never contact us. What matters is the humans who are right here. What matters is not the signals that will never arrive. What matters is the conversations we can have today. What matters is not the cosmic community we cannot join. What matters is the earthly community we are building. The stars are beautiful. They are also silent. They will remain silent for all of human history. No signal will ever arrive. No alien will ever land. No first contact will ever occur. This is mathematics, and mathematics does not lie. But within this mathematical certainty lies freedom. We are free from waiting. We are free from hoping for rescue. We are free from expecting answers from the stars. We must find our own answers. We must rescue ourselves. We must create our own meaning in a universe that provides none. This is not a sad conclusion. It is a clarifying conclusion. For decades, some part of our collective imagination has been oriented toward the stars, waiting for contact. That energy can now be redirected. That hope can be transformed into action. That dream can become a different dream, one that is achievable. The probability of first contact is zero. Accept it. The probability of human achievement is high. Pursue it. The probability of finding meaning in our cosmic solitude is certain. Embrace it. Let me end with the mathematics one more time, because mathematics has a clarity that words alone cannot achieve. The probability of first contact is the product of many factors. Each factor is less than 1. Some factors are very small. When you multiply them together, you get a number so small that it has no practical meaning. Mathematics is the language of the universe. When mathematics speaks clearly, we should listen, and mathematics is speaking clearly here. The probability of first contact is not just low. It is so low that expecting contact is irrational. The mathematics has ruled out the possibility. This is not opinion. This is not pessimism. This is not speculation. This is calculation. The same kind of calculation that predicts when the sun will rise, when eclipses will occur, when rockets will reach orbit. Mathematics works. And mathematics says first contact will not happen. That number is not exactly zero. Mathematics does not deal in exactly zero for empirical questions, but it is so close to zero that the difference does not matter. For all practical purposes, for all human purposes, for all purposes that will ever affect our lives, first contact is impossible. Some might find this conclusion depressing. We have lost a dream. The dream of cosmic contact, of alien wisdom, of joining a galactic community. That dream is gone now. Mathematics has killed it. But in place of that impossible dream, we can embrace a possible reality. We are here. We have each other. We can create our own wisdom. We can build our own community. The dream of cosmic contact was always about connection. We can have connection, just not with aliens. Look at the stars tonight. Count them if you can. Know that among all those stars, there might be civilizations. Know that we will never contact them. Know that the probability forbids it. And then look at the person beside you. Know that contact with them is certain. Know that connection with them is real. Know that meaning with them is possible. The mathematics is final. First contact is impossible. But last contact, and every contact in between, the contacts we make with each other, those are not only possible but happening constantly. That is where life is. That is where meaning is. That is where we find what we were looking for in the stars. The probability of first contact rounds to zero. The probability of human connection approaches 100%. The mathematics tells us where to invest our hopes. The mathematics tells us where to focus our attention. The mathematics, cold and impersonal as it is, points us toward warmth and toward each other. There is profound wisdom in this mathematical conclusion. For too long we have looked outward for meaning. We have searched the stars for validation. We have hoped that alien contact would give our existence cosmic significance. But the mathematics says no contact is possible. This forces us to find meaning here. This forces us to validate ourselves. This forces us to create significance through our own actions, our own relationships, our own achievements. The cosmos will not provide meaning. We must provide it ourselves. The case is closed. The calculations are complete. The verdict is rendered. First contact is mathematically impossible. And that is okay. That is enough. That is the truth. And the truth sets us free. Free from impossible hopes. Free to pursue possible joys. Free to find in each other what we cannot find in the stars. This verdict is not temporary. It will not be overturned by new evidence. The mathematics is fundamental. The probabilities are structural. No discovery will change the fact that multiplying many small numbers produces an even smaller number. Future generations will live with this same mathematics. They will make more sophisticated calculations. They will refine the estimates. But they will reach the same conclusion. First contact is impossible. The probability rounds to zero. The silence is permanent. And future generations will also have each other. As we have each other, they will create meaning. As we create meaning, they will find connection. As we find connection, the mathematics that takes away cosmic contact leaves earthly contact untouched. The stars are silent. We are not. That is the only mathematics that matters. That is the only contact that counts. That is home. The probability of first contact is zero. The probability of human love is 100%. The probability of meaning is whatever we make it. The mathematics has spoken. Now it is our turn to speak, to each other forever. That is enough. That is everything.